Hi everyone, welcome to my YouTube channel Erudispace. I am Dr. Mohanty and today we will discuss about the reduced ambient air cooling system. The reduced ambient air cooling system finds extensive application in high-speed aircrafts. We will discuss the system with a detailed schematic diagram and then we will discuss the different thermodynamic processes with the help of a temperature entropy diagram. So the different components of the system are your diffuser, your compressor, your combustion chamber, your gas turbine, then your heat exchanger. You have two cooling turbines, then your first cooling turbine and second cooling turbine, then you have a cooling fan and you have a reduction gear arrangement. Now we discuss how the system actually works. First, the ambient air is done into the system. It is made to pass through the diffuser. Diffuser is a smoothly varying section which converts the kinetic energy into pressure energy. So after passing through the diffuser, the temperature and pressure is raised and this air is known as your ram air. After that, it enters the compressor. In the compressor, its pressure and temperature is further increased and a major portion of the compressed air is then taken to the combustion chamber. In the combustion chamber, heat and fuel is added to the air. Then combustion of the air fuel mixture takes place. Huge amount of thermal energy is developed and then this high pressure, high temperature gas is taken to the gas turbine where it expands and does some mechanical work. This actually gives drive to the aircraft and a part of the energy that is developed is utilized to run the compression. The remaining amount of compressed air which has not been taken to the combustion chamber is actually made to pass through the heat exchanger. And in this system, it is cooled by a fraction of the ram air. But particularly when it comes to high-speed aircrafts, the temperature of the ram air is also very high. To provide effective cooling, it is actually made to pass through the first cooling turbine. So after passing through the first cooling turbine, its temperature is significantly reduced so that it provides effective cooling to the air that is drawn from the compressor. And then after being cooled by the air which is coming from the cooling turbine, the air is taken to the second cooling turbine. In the second cooling turbine, it further expands and due to this, its temperature is further reduced. Then this air is taken to the cabin or cockpit from where it receives heat from the space to be cooled and it actually produces the desired refrigerating effect. The power that is developed is actually utilized to run the cooling fan and this actually drives the cooling fan through this reduction gear arrangement and the cooling fan actually helps in drawing air from the heat exchanger. So this is the way actually the system works and now we'll discuss the entire cycle with the help of a temperature entropy diagram. And here we'll consider what is happening to the air which we call your bled air which is drawn from the compressor. And particularly used for the refrigeration purpose. Now, we have 6 processes: 1, 2, 2, 3, 3, 4, 4, 5 and 5, 6. And you do have 4 operating pressure conditions. They are your ambient pressure, that is the pressure when the air is taken in. Then you have cabin pressure, that is the pressure that is maintained in the cabin or cockpit. Ram pressure is the pressure after passing through the diffuser, and the main compressor pressure is the pressure after passing through the compression or after being compressed in the compression. 1, 2 actually represents the ram compression, and this type of compression doesn't require any work to be done upon the system, because the compression is due to the shape of the diffuser. Then 2, 3 represents the compression that is taking place in the main compressor. Here we need to do some work to compress the air. 3, 4 actually represents the cooling that is taking place in the heat exchanger. And we need to remember one thing, that the cooling is done by the air that is coming from the first cooling turbine. Because already I have told you that although the temperature of ram air is lower than the temperature of air that is coming from the compressor, particularly when it comes to high-speed aircrafts, it is significantly higher. So it is made to pass through the cooling turbine, and 3, 4 actually represents the cooling of the air by means of the ram air which has already passed through the fast cooling turbine. Then 4, 5 represents the expansion which is taking place in the second cooling turbine, and 5, 6 represents the refrigeration process which is taking place in the cabin or cockpit, where the air which is being used as a refrigerant receives heat from the space to be cooled. As a result, its temperature is raised from T5 to T6. Now, the coefficient of performance of any refrigeration system is represented by COP is equal to the refrigerating effect divided by work done. Now, if M is the mass of air that is bled off from the compressor, particularly for refrigeration purpose, and Cp represents the specific heat at constant pressure, the refrigerating effect is represented by mass of air bled off multiplied by specific heat at constant pressure multiplied by temperature difference, that is T6 minus T5, because it is entering the cabin or cockpit at 5 and leaving at 6, divided by work done. Work done is mass of air that is bled off from the compression for refrigeration purpose multiplied by specific heat at constant pressure multiplied by the temperature difference. The temperature difference is T3 minus T2, because it is entering the compressor at 2 and leaving at 3. We have not considered the work done when it comes to ram compression, because no work is done upon the system in ram compression. So this is equal to T6 minus T5 divided by T3 minus T2. So we have considered both the stages of compression, that is both the ram compression and the compression that is taking place in the main compressor, to be isentropic processes. Similarly, the expansion that is taking place in the second cooling turbine is also considered to be isentropic. But if you consider the effect of irreversibilities, all these processes will take place with some increase in entropy. So the ram compression will not be 1, 2, rather it will be 1, 2 dash. Similarly, the compression that is taking place in the main compressor will be different, and this point will not be 3, rather it will become 3 dash. Similarly, when you are considering the expansion, it will not be 4, 5, it will be 4, 5 dash, and 5 dash will be placed somewhere here. Now I sincerely believe that your concept about this reduced ambient air cooling system would be crystal clear. This is in fact the 6th lecture taken by me related to aircraft refrigeration systems. We have discussed in detail the simple air cooling system, the simple air evaporative cooling system, then the bootstrap air cooling system, bootstrap evaporative cooling system. Then we have also considered the regenerative air cooling system. So if you have any doubt related to all these lectures, please do put questions so that I will try to answer. Thank you very much for watching this video. I would request you to subscribe to my channel if you have not done so till now. I would further request you to share this video with your friends and relatives to improve its visibility. Thank you very much for your cooperation. Hope to see you soon for another lecture on my YouTube channel, Erudispace.